In this lesson, we're going to introduce some fundamental concepts behind full-text search, including text analysis, inverted indexes, and scoring. We'll also provide an overview of how you might approach designing full-text search behaviors for your applications. Now, in this course, we're focused on full-text search, so let's jump into some fundamentals. We'll start with text analysis. So imagine you have a document that includes this sentence, and you want it available for full-text searching. Now the first step would be to tokenize the text. Chop it up into individual pieces, called tokens, and maybe remove unnecessary punctuation along the way. Then you might flatten things a bit, perhaps reducing everything to a common case. Of course, these behaviors could vary in different languages. You'll then want to remove what are called stop words, which are words so common, like and, but, and or, that searching for them could just skew your results. Then you could reduce similar words, like beauty, beautiful, and beauteous, to a common root or stem, like maybe just beauty, B-E-A-U-T-I. Then you could conform similar spelling variants to a chosen norm, which might mean, for example, removing the U from the English spelling of the word color and just storing color spelled in a single way. Now, once all this is done, you have a useful set of terms to index and search. Now, notice there that I said both index and search, because you need to analyze your text and process it in the same way, both as you store it and as you look it up, usually. So if I were indexing a phrase like color deal with English spelling and an exclamation point, I might run it through an analyzer which reduces it to two terms as shown, color and deal, no punctuation and a common spelling. But that means if later I'm searching for the phrase colorful but deadly beauty, then I normally need to analyze and process it in the same way. So I run my search phrases through the exact same analyzer. In this case, I'd end up matching the index term color to the search term color. Now, a full-text search system stores all these terms in what is called an inverted index. This index tracks individually analyzed terms along with each document where they appear and where exactly they are located within each of those documents. This way, when a term is matched in the index, the engine knows exactly where to find each individual occurrence of that term within your entire data bucket. The problem, of course, is that you may have lots of results. The same term could show up several times and in many different documents. This is where scoring comes into play, to help determine priority. Scoring is based on two things. First, term frequency. The more commonly a word appears in all your index documents, the more likely it is to be, well, common, unimportant. However, scoring also looks at individual document frequency. The more often a word appears in the same document, the more likely that term is important within that particular document. Well, you run some math over these values, and you end up with a score evaluating the relative importance of each hit in your search results. These scores are then used to sort your hits, at least by default, with the most important result appearing first. Now, like a lot of things in the software industry, designing a good full-text search index is as much art as science sometimes. You gotta know your data. But you can break the process down a bit. First, figure out what precisely needs to be searchable in your documents. Now, you can index everything. That's not very efficient. You want to identify whether it is all your documents and all fields in your documents, or perhaps only those of one or more specific document types, and then you restrict your index using your type identifier. Then you map the particular document sections and specific fields to be indexed and searchable. Last, you'll configure the individual fields to be indexed for their particular search type, generally meaning text, numeric, date, or Boolean, as well as related behaviors such as whether field data should be stored in the index for retrieval directly with the results. Next, you need to consider how the data should be analyzed. How should the text in your documents be segmented and filtered? Now, during indexing, unwanted characters could be excluded. Then your incoming text stream was split into individual segments, again called tokens, which generally speaking means chopping up individual words in a sentence using Unicode values, particularly relying on spacing between individual terms. Then those tokens are run through one or more filters to do things like knock out your stop words, those terms so common there's no point in searching for them. They don't ever get indexed. Last, you then need to consider how you will run full-text searches, or queries as they are technically called, particularly in the REST APIs. You'll choose your preferred approach, REST API, SDK call, or, at least for learning and testing purposes to a degree, just running them through the Couchbase UI itself. You'll choose which query type or types to run, such as match or range or Boolean queries, potentially adding specific modifiers to certain terms in a given query. Last, you'll determine whether the default sort order works for you and if you want your data faceted or have group statistics gathered in some manner. In the end, you get back a JSON document full of sorted results, again also known as hits, with robust supporting data including facets. In the lessons ahead, we'll be learning how to do all of the above using Couchbase full-text search. So what have you learned here? Now, text analysis means generally to tokenize text and create a useful set of terms. The same analyzer generally would be used for both indexing your text as well as processing incoming search strings, so things line up with each other. Inverted indexes track each specific document and document offset where each analyzed term resides. The frequency of terms in the index, coupled with the frequency of a term within a given document, are used to generate a relevancy score for sorting purposes. Full-text search design is an iterative process requiring strong knowledge of your underlying data. You will design indexes including field mapping and configuration, consider and potentially customize how incoming text is analyzed, and then plan and design your queries and their related behaviors. Again, we'll be learning all of this ahead. We hope you stick around. There's a lot more to come.